Hello everyone, I am Harsha Kumawat. I am currently working as the Data Science and Business Analytics intern at Sparks Foundation. I have completed task 1 of my internship. Task 1 is basically prediction using supervised machine learning. The problem statement here is predict the percentage of a student based upon the number of study hours. Here simple linear regression is used because we have only two variables. One is the target, that is the percentage score of students, and another is the predictor, that is the number of study hours. So the step 1 is to import the necessary libraries for data analysis and data visualization. Second is to read the data from the particular source URL, that is basically importing the data into the pandas data frame. Next is to view the data, we use the head function. So here we can see that the data set consists of two columns. One is the number of hours of study and the second is the percentage score. Next step is exploratory data analysis. Dot shape helps us to understand that 25 rows are present in the data set along with two columns. To check whether any null values are present, we are using isNull.sum function. So here we can see that no null values are present. To get the basic information about the data frame, we are using .info. It tells us that it is a pandas data frame. It gives us the range that varies from 0 to 24, consisting of 25 entries. It gives us the total number of columns. It gives us the column name along with the total count of value present in that particular column, along with the data type and the memory usage. Next, to get the statistical summary of the data, we are using .describe function. So it gives us the total count, the mean value, the standard deviation, the minimum value, the 25% value, the 50% value, that is the median, the 75% value, the maximum value of the hours and score column. Next is finding correlation between hours and scores. So here we can see that scores and hours have 0.97 correlation. That is a very good correlation value between these two variables. Next, we are using Seaborn library to plot the red plot between number of hours and percentage score of students. So here we can see there is a positive linear relationship between number of hours and percentage score of student. That means when number of hours is increasing, the percentage score of students are also increasing. Next is prepare the data, where we are going to divide our data into the dependent and the independent variable. Independent variable is basically x, that is our number of hours of study, and dependent variable is y, which is the percentage score of the student. Next step is to divide the data into the training and testing part using the train test split method of the scikit-learn built-in library. After that, the next step is model training, where we are going to import linear regression from sklearn.linear_model. And then we are going to create the instance of linear regression class so that we can use that instance to train our model based upon the training data set. So once the training has been complete, next step is to get the coefficient of the regression line. So once we get the coefficient of the regression line, that is the slope and the intercept, using the linear regression equation, we can plot a regression line basically. So the linear regression equation is basically y equals to mx plus c, where m represents the slope and c represents the intercept. So using the same linear regression equation, the regression line has been plotted. So our model is able to fit the best fit line on these particular data points. Now the next step is to test the model based upon the training data set. So to test the model, we are using lm.predict to predict the y-test values based upon the x-test, that is our independent variable. After that, we are finally comparing our actual values and our predicted values. So here we can see that our actual values is 20 and our model predicted the value as 16. So the difference between actual and the predicted value is basically known as residual, that is the error basically. So our problem statement was, what will be the predicted score if a student studies for 9.5 hours per day? So we are predicting it using our linear regression dot predict function, basically that the instance of it lm dot predict to predict the percentage score. So we are providing a number of hours in our numpy array so that our linear regression model predict our percentage score. So the percentage score is 96.169, where the number of hours studied is 9.5 hours per day. Next, and the final step is model evaluation, and here I have used the mean absolute error, the mean square error and the root mean square error to find out how well our model is performing. So lower the error value, the better our model performs. Next is the estimated training and testing score. So the training and testing score are very good, because for the training score it is 0.95 and the testing score is 0.94. So it is a very good value for the training and testing score. Last one is the R square. So the R square value is 0.945. R square is basically the statistical measures. It tells us how close the data points are to the fitted regression line. It is also known as the coefficient of determination. So here we have the very good R square value for our linear regression model. And the last, this is a summary I have wrote based upon the insights that I got by performing the above task. So the final conclusion is, I was successfully able to carry out the prediction using supervised machine learning and was able to evaluate the model performance. Thank you.